Good morning, everyone. Myself, Leela Sravanthi, working as assistant professor in CSE department, Mlritm. Already, we have discussed about the topic of security attacks in the cryptography and network security. For that one, next we are having of a security services. Security services. How the after completion of the security attacks, the security services will be used. It is a process service that enhance the security of data and data processing systems and information transfers of an organization. In this, the services are divided into the 5 categories. First one is the confidentiality. For confidentiality means it can be accessible only by the authorized parties. Okay, example is the displaying and other forms of disclosure. Printing. The next one is the authentication. Authentication is used to whether the person who are logging into that one is the true person or the false person. It is a identity of a person. Okay, document is currently identified or not. It will be checked by in this authentication. And next is the integrity. Integrity is it is used for the authorized persons, and it is also can be able to modify in the computer system, and it is transmitted the information, modification of a modification in the computer system, and it is transmitted the informations. The modifications can be the writing, changing the status, deleting of a messages, or creating of a new messages. These are the integrity process. The next one is the non-repudiation. Non-repudiation is requires that it is whether the message is transmitted or not. It is denied the transmission or not. It is identified in this non-repudiation. This is neither the sender or the receiver of the messages is denied of the transmission. The next is the access control. This access control is to access the information resources controlled by the target system. The next is the availability. Availability requires the computer system assets be available to authorized parties when needed. Okay, the assets. It is if the messages are required for the authorized persons, it can be present in that one. They can use that availability messages. The next is the security mechanisms. Security mechanisms is one of the most specific mechanisms we are using in the cryptographic technique. Okay, in this one, encryption is a transformations of information are the most common means of providing security. Okay, in this one, first we are having of a specific security mechanisms. In that one, first one is the encipherment. This encipherment is used to transform data into form that is readily intelligible. Okay, then the transformation is subsequent, and recovery of data depend upon a algorithm, that is a 0 or more encryption keys can be used. The next is a digital signature. Digital signature is a cryptographic transformation. Okay, this example is the recipient. The data can be the data unit, and it will be protected against the forgery. That is the use of this digital signature. The next is the access control. Access control is accessing rights to the resources. The next is a data integrity. It is used to assure the integrity of a data, and the data is in the format of a stream of data units. The next is the authentication entity. It is used to identity an entity by means of information exchange. Information can be exchanged between the two persons. The next is a traffic padding. Traffic padding is used to insertion of a bits. Insertion of a bits into gaps in a data stream. Okay, the next is a routing control. Routing control, it is used to enables the selection of particularly physically securing routes, and it is allows to the route changes. Okay, then last one is the notarization. It is a trusted third party to ensure the properties of a data exchange. These are the security mechanisms: security attacks, security services, and the security mechanisms. The next is the network security model. Okay, here the message is transferred from one party to the another across some sort of internet service. In this, there are the two parties. That is a principles in the transaction. Okay, the transaction and exchanging of a data can take place. In this, the logical information channel is established by defining the route, okay, through the internet, and the destination by the cooperating use. The communication protocols is calling as the TCP and IP. Okay, here when coming to this model of a network security, here it is related to send the information. Okay, here in this one, the sender and the receiver are there. Okay, which is used to verifying of a sender, whether the message is sending by the sender or not. In this, the sender is sending of a message. Okay, that message is secured here, and here this is the send message, and this is calling as the opponent. This opponent will be acting as an interface between the user and the receiver. That is a sender and the receiver. Okay, that is a sender or the recipient. Then next, the messages will be sent here. Then the security information will be transferred to this one. Then the message is getting. Okay, when the sender is sending of a information, just it will be sending the data by the using of this trusted third party. Okay, the information will be exchanged between the third party, exchange between this third party and the sender, and recipient and this sender. The information will be transferred between this opponent and this channel. Okay, in this format the messages will be sent. But how the security will be provided? See here, the information can be accessed. The opponent, this opponent will be the humans, and this will be acting as the gatekeeper. Okay, the information will be transferred in this format. That is this access control will be acting as a opponent, means the sender is sending of a message. How the message will be designing of a particular security service is provided, means the algorithm such that an opponent cannot defeat its purpose. Okay, and here generating of a secret information. This opponent, this sender will be sending of a information. This opponent will be sending generating of a secret information. Okay, secret information used with the algorithm, and it is used different methods for the distribution and sharing of a secret information, and it is also used for the different protocols verifying of a security algorithm. And how these figures has been able to see here, whenever the messages has been sent from the sender to the recipient, if any of the unwanted messages are displaying, that will be identified by the system, by this opponent. Why? Because this opponent is generating of a secret information that is sent to this recipient. Okay, This is the network security model. This is how the information threat can be used and how the unwanted access of a placement can be done in the computer system, that may be in the format of a logical or different application programs. Okay, here the information, there are the when the program has been sending, program can be present in two kinds of threats. First one is the information access threat and the service threat. This information access threat is to modify data. Okay, information access threat. It is used to modify the data behalf of the users who should not have access to that data. Okay, if the sender is sending the message, the user access, if this third party is not having access that data, they can use to change the data and it is ready to send to the recipient. Okay, that is who should not have access to that data. Then next is the service threat. Here services will be flaws. Means the different the service, the exploiting the services flaws in the computers to inhibit use of the legitimate users. Just the whatever the network we are using, if getting any of the information for false information, just we are not able to use that one. That is the use of this service threat. Okay, the next is the what are the basic terminologies we are using in the cryptography. Okay, first is a symmetric cipher model. Okay, here see in this one the ciphertext. Here the ciphertext is the coded message. Cipher, the algorithm for the transforming of a plain text to the ciphertext. Here this is the message. This is the encryption algorithm, encrypted message, decryption algorithm, and the original message. Means the plain text is converted to the ciphertext by using of this encryption key. Okay, then after decrypting of this key only the original message will be displayed. Okay, this is the transforming of a plain text to the ciphertext. Then next is the key. What is the use of this key? It is the information used in the cipher. Okay, cipher, that key is only known to the sender and the receiver to see this ciphertext. Then encipher or the encryption. Encryption is used to converting to the plain text to the ciphertext. Decryption is a recovering of a ciphertext from plain text, or we can tell that the cipher conversion of ciphertext to the plain text. Then the what do you mean by the cryptography? It is a study of encryption principles or methods. Okay, the next, that is a cryptography. The next is a cryptanalysis. That is a cryptanalysis is a code breaking. This is a study of both methods of deciphering text without knowing the key. Okay, deciphering. Then next cryptology. Cryptology is calling as the both the combination of cryptography as well as the cryptanalysis is calling as the cryptology. Okay, when we are converting of a encryption to the decryption, this when the encryption type conditions is developed of the public key encryption in the 1970s. Okay, this is also referred in the format of a symmetric encryption. Okay, this is the basic terminologies we are using in the cryptography. Here see how the simplified of a symmetric encryptions can be done. This is a plain text. It is a encryption algorithm. Then the transmitted of a ciphertext. Then key has been given. Then the decryption algorithm, and it is a plain text. Here the secret key is shared. Okay, secret key is shared by sender and the recipient. Secret key is shared by the sender and the receiver. Then this plain text will be displayed here. Okay, this a key will be given here, encryption algorithm. Then the decryption algorithm also we are giving this shared key and we are getting offers original. Before that one, this is calling as the ciphertext. Okay, the original text. Okay, the original text is referred as the plain text and it is converted to the random ciphertext. That is a random conditions or random sentence or the nonsense, that is referred to as the ciphertext. For this encryption process, it is consist of the for the encryption process consisting of an algorithm and a key to transmission of the plain text to the ciphertext. Then the key will be the independent of plain text. This key, whatever the key has been shared by the sender, that will be the independent of that plain text. Okay, this key and this plain text will not be in the same format. It is a totally independent. Okay, then next. Then changing of a keys, the output of the algorithm. Then the ciphertext is produced, it may be transmitted. And this original plain text by using of a decryption. Then decryption algorithm will be given and here whatever the secret key has been provided by the sender, that will be given here, the original plain text will be getting. Okay, these are the conditions. When we are using of these two requirements, the securing of a symmetric encryption, that will be the two requirements. The strong encryption algorithm, a secret key is known to the sender or the user. Okay, here EK of X, DK of X. EK is a encryption key of X, decryption encryption key of K, decryption key of Y. Okay, these are the two requirements we can use for the model for the symmetric encryption. Okay, the next is what are the cryptographic concepts and the techniques has been used. The cryptography, symmetric key, asymmetric key cryptography, and the symmetric key has been divided into the two types, classical and the modern. Classical cryptography has been divided into the two, transposition cipher, substitution cipher. Modern cryptography, stream cipher and the block cipher. Okay, we will see the differences between the symmetric key and the asymmetric key. Symmetric key, it allows a single value for the both encryption and the decryption. Okay, only one key. But while coming to the asymmetric key, it requires two keys, that is a public key and the private key for the encryption and the decryption. Then the cipher of the size of the ciphertext should be the smaller than the original plain text, but the size of the ciphertext is the same as the original plain text. Okay, the encryption process is very fast in the symmetric. The encryption process is slow in the asymmetric key encryption, and it is used for the large amount of data needs to be transferred. Then it is used for the asymmetric key is used for the confidentiality, authenticity and the non-repudiation. Okay, then it provides the confidentiality. It is used for the large amount of data and it is used for the small amount of data. Then the length of a key must be used between the 128 or 256 bits. But while coming to the asymmetric key, the key used is a 2048 or higher. In symmetric key encryption, resource utilization is low compared to the asymmetric. Then while coming to here asymmetric, resource utilization is high when compared with the symmetric. The next is it can be handling of a large amount of data, and the efficient handle can be used of a small amount of data. Okay, the security is lower Okay, in this one, both encryption and decryption purposes. Here, while coming to this one, the mathematical representations. P is equal to D of KE, KP. Here, K will be indicating of encryption and decryption. P is the plain text, D is the decryption. Then E of KP is the encryption of plain text. Here, for the symmetric key encryption, DES and the RC4 are the examples, and AES. Then while coming to here, the mathematical expression is a D, K of encryption, K is the encryption key, KD is the decryption key, and D is the decryption key. And here EK of P is the encryption of plain text using encryption key. Okay, here the examples of this one is the Diffie-Hellman, RSA and the DSA. Okay, this is the differences between the symmetric and the asymmetric key. Then first we will go for the symmetric key. Here the symmetric key cryptography has been divided into the classical and the modern. The classical cryptography has divided into the transposition and the substitution cipher. Okay, in this one, first we will go for this classical encryption techniques. Okay, there are the two basic building blocks of encryption techniques are there. That is a substitution and the transposition techniques. Here, the substitution technique, it is one in which letters of plain text can be replaced by the other letters. Okay, that may be the numbers or the symbols. The plain text can be viewed as in the sequence of bits, but when substitution involves replacing plain text patterns with a ciphertext bit pattern. Okay, that is a substitution technique. But while coming to this transposition technique, the substitution of the ciphertext symbol for a plain text symbol, it is very different kind of mapping is achieved by performing some sort of permutations to the plain text letters. This technique is referred as the transposition cipher. Okay, this is the classical encryption techniques. Okay, while coming to this one, substitution techniques, we will go for the substitution techniques. Substitution technique, here substitution encryption technique is one of the classic encryption technique. It is used, substitution technique is one in which the letters of plain text are replaced by the other or by numbers, other letters or by numbers or symbols. Okay, if the plain text is viewed as a sequence of bits, the substitution involves replacing bit patterns with cipher bit patterns. Okay, these are the types of substitution technique. Substitution technique has been divided into the 6. First one is the Caesar cipher, monoalphabetic cipher, Playfair cipher, Hill cipher, polyalphabetic cipher, one times paired cipher. Okay, these are the 6 substitution techniques. Okay, first we will go for the Caesar cipher. Okay, Caesar cipher is also called as a shift cipher. Here the Caesar cipher is a type of shift cipher. The shift ciphers will work by the modulo operator, okay, to encrypt and decrypting of messages. Here the shift cipher will be as a key. Okay, the key will be represented as the K. Okay, that integers, the integers is taken from the 0 to 25. Okay, the next is the Caesar cipher will involve replacing each letter of the alphabet with the letter standing. For example, okay, this is a primary features of the primary features of this cipher. Okay, it uses a fixed key, and we call this as the shift. Fixed key we are giving, that we are calling as the shift. The key or shift is the number positions such as letters, such as number of positions each letter, and is shifted from both the sender and the receiver. Known this key. Okay, that key should be known to both the sender and the receiver. Okay, that is a next. That is the first one. The next one is due to its simplicity, Caesar cipher has used as a teaching tool in the basic concepts of cryptography. The Caesar cipher is the symmetric. Okay, it means it uses the same key for encoding by the sender and decoding by the receiver. If the same code will be given for the both the sender and the receiver. Okay, in this one, the English alphabets only 26 letters are there. In this method, you can use only the 26 possible keys. The limits is the key space. Here, when we are using of this 26 possible keys, the easy attack is try all options for the break the cipher. Okay, for that one, for this seriously security needs, the Caesar cipher can add basic level of security for to the messages. Okay, this Caesar cipher is simple to use, only needs basic arithmetic, and it is making popular as a simple encryption method. These are the primary feature for the Caesar cipher. Okay, for example, this is a Caesar cipher. Here we are taking alphabets A to Z. Okay, that is a 1 to 26. But while coming to here, A is replaced, A is taking as a 0, B is 1, C is equal to 2, and up to Z, that is a 25. Okay, for each substitution of a letter, just we are writing in this format. See, for example, Caesar cipher encrypting of a message, hello. The shift is key. The shift will be referred as the key. Okay, first write down the plain text as the hello. Choose the shift value. What is the shift value here? 3 is the shift value. Replace each letter in the plain text with the letter of the 3 positions from the alphabet. Okay, this is a box we have written for that one. Okay, then from that one, the H, from the H, the H, H-E-L-L-O, H is shifted to 3, means I-J-K. H is replaced with the K value. The next is the E. E is replaced with the shift of 3, F-G-H, H. And next is the L. L is replaced with the 3, M-N-O, means O. And L is also replaced with the double O. Then O is replaced with the P-Q-R. Okay, shifting of a 3. Shifting of a 3. That is a K-H-O-O-R. Okay, this is the cipher text for the plain text. Here see, that is a shift 3 H K H O R. Okay, this is the encrypted message for this hello. How the encryption process is done and how it is converted from the plain text to the cipher text, that is calling as encryption technique. Okay, and another example, the original message that John wants to send to the Joe is call me tomorrow. The shift is 3. Okay, then how we are able to take that one? Call me tomorrow. See here, call shift 3 means DEF. Okay, F. This is a F. The next is a D, E, F, G. Okay, A, B, C, D. Next is a D. And here the cipher text of this one, Caesar cipher applied to this call me tomorrow, and the cipher text is a FDOOPHWRPRWRZ. Why? Because the numbers will be shifted 1, 2, 3, 1, 2, 3. C is shifted to F. That's why we have written of F. A is shifted to D. We have written of D. And L is shifted to O. We have written of 2. And M is shifted to P. and E is shifted to H. E is shifted to H, and T is shifted to W, O is shifted to R, M is shifted to P, and O is shifted to R, and R is shifted to U, R is shifted to U, and O is shifted to R, W is shifted to Z. Okay, in this process, the Caesar cipher can be applied. This is the encryption process. But the decryption process, while coming to the decryption process, the shift of 3 can be done in the backward. Encryption process can be done in the forward, and decryption can be done in the backward. Okay, the same number of positions can be taken. The ciphertext is converted to the plain text. That is calling as the decryption. For example, same, take that one, KHOOR. This KHOOR is shifted back by the 3 positions of to get the original message. Means here K, first one is the K. K is shifted to backside. JIH. Okay. Then next is the KHOR. H is shifted to next. That is a GFE. The next L is shifted to back. L is shifted, O is shifted to back. NML. Okay. Then next L. Then R is shifted to back. O. Okay. In this process, ciphertext to the plain text. Okay. Converting of a plain text to the ciphertext is calling as an encryption technique, and the conversion of ciphertext to the plain text is the decryption process. Okay. This is a Caesar cipher. Thank you.